First thing I did on that one was graph this in the calculator and also graph y equals 4 in the calculator. And I let the calculator find that intersection point for me. And then for part A, you're supposed to find the volume about the line y equals -2. So y equals -2 is down here. Here's our axis of revolution. And this is the A-B test, so it's going to be the disk method. Everything is in terms of x's. You want your rectangle drawn that way, so that's a dx problem. And it's perpendicular, which we said is going to be the disk method. And then when we do the capital R is going to be the distance from your axis of revolution to the farther edge of your bounded area. So you're measuring from here to that straight edge every single time. So here to here is 4 units, here to here is 2 units, so 4 plus the 2, that's going to give us 6 for the capital R. The little r is a distance from that axis of revolution to your closer edge. You're used to when you measure from the x-axis up, that's y, but you started back here. So you traveled 2 units, and then you went to from the x-axis up, which is y. So you got 2 plus y, that's your little r. And then that little r is your closer edge. That's that equation right there, your f of x equation. And then once I got my capital R and the little r, just combine some like terms there. I did my pi guy out front, my capital R squared minus that little r squared. You're not meant to do this by yourself. This is the calculator part of the test. Enter that. Please practice that into the calculator so you get comfortable with it. You get quick with it. It's just math 9, that thing. You got to show your setup. And then I will put the pi in there first so you don't forget to do that. And then since it's a dx problem, you're going left to right. Use the x's that take you across that shape. That's why you needed that 2.3 number and then rounded 3 numbers after the decimal there. So there's part A of straight to a volume problem there using that disk method. Now the next one is with your cross sections, all right? It tells us perpendicular to the x-axis. A little tricky. The first time we've ever seen something like this is as an isosceles right triangle. So we'll handle that in a second. But regardless of what the shape is, it says perpendicular to the x-axis. So what I did is I draw a line segment perpendicular to that x-axis, call that S, and you find the length of that S. It's going to be top y minus the bottom y. So I did top y minus the bottom y. So the top curve was 4. Your bottom y was your f of x equation. I distributed, combined it. There's my S right there. Now, if our cross sections are squares, you integrate S squared. You integrate the area of your cross section shape. So if you have squared, you integrate S squared. You integrate that thing squared. If you have equilateral triangles, that's radical 3 over 4 s squared. You would integrate radical 3 over 4 times that thing squared. If you have semicircles, this would be your diameter. You would integrate pi r squared divided by 2, which means you need to divide this by 2. That would be your radius. And then you integrate pi times that r squared divided by 2 right there. Those are the ones that pop up a lot. If they have rectangles, this would be the base of your rectangle. They would have to tell us the height is equal to 5 or the height is equal to 3, and then you just do that times 3 or that times 5. But isosceles right triangle, I remember the year that my students took this. Some of them walked out of there, they were a little confused on that. Some of them were using that radical 3 over 4 s squared formula. That's only for an equilateral triangle. So isosceles means 2 sides are the same, and it's a right triangle. So the area of just a normal right triangle is just 1/2 base times height. And then if it's isosceles, that means the base and the height are the same. They're congruent sides right there. So the base and height are the same. And that's what your S is the base. And then so this is really what you're talking about here. And you just want to do the area of that triangle. It's just 1/2 s squared. So as long as you remember for cross sections, you're going to integrate the area of your cross section shape. And then just think about what that shape's about to be, 1/2 s squared. So that's why I got 1/2 times that thing squared. And then left to right, use the x's that take you across that shape. Goes 0 to 2.3. Math 9 that sucker. Remember to square it. Make sure you're comfortable getting that number right there. And then the last part of that, it says x equals k is a vertical line that divides us into 2 equal areas here. So I went to my picture and I drew in x equals k. I drew in a vertical line there. The left area is equal to the right area, which means I can go top curve minus bottom curve from 0 to k, top curve minus bottom curve from k to 2.3. As I go left to right, those are the x's that we're using there. So one way you could do this is I just integrated top curve minus the bottom curve. That was 4 minus that. Now I already did that here, 4 minus that. already knew what that simplified to. So I just kind of carried that over. That's why I said that was my top y minus bottom y. And notice all I'm doing here, I'm setting the left area equal to the right area. So I went from 0 to k, set that equal to the integral of k to 2.3, and it's still the same top curve minus the bottom curve. Those insides are going to be the same. Those two things are going to be equal to each other. It says write, but do not solve an equation. It says an equation, so you got to make sure there's an equal sign in there. You can't just like write that one down. You got to do something with the equal sign. Another thing that you could do here is if you wanted to, you could just integrate from 0 to 2.3 of that top curve minus the bottom curve. It'll give you the total area, cut it in half, and you can take the left side and set it equal to the 1.609. You can take the right side and set it equal to 1.609, or you can just set them equal to each other there. I have seen some problems where they will have us solve this for the k. If they did have me solve this for the k, I would need to integrate this like negative x to the 5th over 5, 2.3x cubed x to the 4th over 4, plug in the k, plug in the 0, and then you set it equal to that. And then you have one equation with k's in there that you'll be able to solve that for k. But typically when they have us do that, they make those a little bit easier to work with right there. But there's some challenging stuff in there, but please keep studying those and practicing those as much as we can there. Male.